two diversions through this. Okay, so we're all being recorded. Okay. Looks like my computer has frozen. No, there it goes. No, before we start, it's actually going to be important to note that the information I present today is the personal opinion of myself, and it may not be indicative of the views of either Standards Australia or Weld Australia. Should you require an official interpretation relating to any Australian ISO standard, please contact Standards Australia directly, and I will give you a very brief overview of this later. For those of you who do have your camera on, could I ask that you please turn it off? Okay. The process to revise an Australian or Australian New Zealand standard is actually outlined on this slide. Whilst anyone can prepare and submit a proposal, many committees delegate this task to the chair of the committee. And as I have said in the past, please be aware that Standards Australia do not have the resources nor the time to revise standards in committee. And as a consequence, well-advanced working drafts are favourably received during project proposals. To put this resource limitation into perspective, there are currently in excess of 250 welding and welding-related standards published, and with many now in excess of 10 years of age, the resources needed to revise all of these standards just do not exist. And it is important to note that irrespective of the origin of any draft standard, it must have strong support from all stakeholders, not just the proponents putting the standard forward. Standards Australia can and do assist with this consultation process. Now, proposals lacking support or with minimal detail on changes required will either be rejected or returned to the proposer to seek wider consultation and review. Now, once a proposal is accepted by the engagement managers, a kick-off meeting must be held, and usually within 6 months. Now, I should say proposal is accepted by Standards Australia. And the committee typically has around 8 to 9 months to complete the initial drafting process in preparation for the submission of the draft to Standards Australia editors for preparation for public comment. Now, for this reason, well-prepared working drafts are favourably received during the project proposal stage. Back in the old days, the chair of the committee would ask members what changes they wanted to see in a standard and proceed from there to redraft the text. Very slow and ineffective use of everybody's time. As I've said previously, Standards Australia just don't have the resources nor the time to revise standards in committee, and it's very, very inefficient. By way of comparison, revising a standards in committee, as was the traditional process, typically took 2 years just to prepare the initial draft. And one standard actually took 10 years to revise. So it has been made abundantly clear that such a long time frames are an aberration of the past and cannot be tolerated. If a revision is not completed in a timely manner, it runs the risk of being cancelled. Importantly, when preparing a draft, drafting personnel should be cognizant of the fact that users may read what is written differently from that intended by the committee. So concise, well-written definitions and clauses in simple English make standards much easier to follow. And just as a side comment, one or two committees that I'm involved with, we have 1 or 2 people who will intentionally try to read things as weirdly and as differently as they can to try and ascertain that it's what we've written there is exactly what is intended to be written there and is intended to be understood. Now, complex text and notes buried under or within tables we know can be difficult to follow, and these should be avoided when drafting standards. And a standard that's difficult to follow only encourages the bush lawyers out there to look for loopholes and take clauses in isolation rather than in context, leading to complex and unnecessary disputation. I should point out too that it is really important when you read a standard is to read it in its entirety. Do not under any circumstances take it clause by clause. You will get into trouble very quickly. Now, Standards Australia's policies for the revision and publications of standards can be found in their Standards Guide SG006. Now, in general, the guiding principles are shown on this slide. For the welding industry, where roles and responsibilities are traditionally reasonably well defined, the limitation on prescribing roles and responsibilities within standards is actually quite challenging, and roles can be assigned to some degree to a competent person. The challenge is then to define what constitutes a competent person. And from a welding perspective, ISO requirements in this regards are somewhat more user-friendly. To this end, with the assistance of Standards Australia personnel, we were able to get ongoing approval for a range of roles and responsibilities across a number of committees. It wasn't universal, but it's nevertheless, we did make some good progress. Now, this was especially the case where we were able to demonstrate conformity with ISO provisions. Examples include welding supervisor, welding engineer, welding coordinator, welding inspector. Other examples include where there are statutory responsibility links within workplace health and safety regulations. Conformity assessment cannot generally be included unless the standard is specifically drafted as a conformity assessment document. For example, AS3920, which is used by the pressure equipment industry. And compliance with these types of standards is usually informative rather than normative. So just to let you know what conformity assessment means, it usually means reference to third parties and the like. It doesn't mean conforming with a specific standard as such. It is important to note that the scope of the standard revision or development must be clearly defined, as only changes within the agreed scope can be implemented. If it's out of scope of the definition as the approved revision, then you'll get an email back to say that your suggestion is out of scope. So by the agreed scope is by default, and that presented to and approved by Standards Australia as part of the project proposal. And limited modification is permitted of the scope at the kick-off meeting, but any request beyond this has to be submitted back to Australia for approval by the drafting committee, should that be necessary. And the reason for this is it ensures that the project does not get into what we call unintended scope creep or a growth phase, because that can cause major publication delays, which we don't want to do. Now, adoption of ISO standards. I'll give you a brief overview of what's happening in that area. Now, adoption of ISO standards has been the policy of the Australian federal government for many years, irrespective of which side of politics was in power. The challenge with ISO adoptions is to ensure that they are technically relevant to Australia's needs, because not all are, and are practical in their application, and that could be a challenge. Many have European origins and do not align well with Australian practices, which are more aligned with North American practices. They are therefore either rejected or for adoption, or need to be modified for local use. Some standards may need to be modified to meet local safety requirements, but are otherwise technically sound. In other cases, a standard may need to have alternative or additional testing protocols added. For example, ISO has attempted to produce a structural design standard, but few, if any, countries have seriously considered adoption, primarily because local conditions and local rules may preclude the use of such a general standard, or the complexities within may make it technically difficult for users to apply. On the flip side, there are some excellent standards that have been adopted, including the ISO 3834 series, which is logical and practical in its application to ensure that the weld processes are under appropriate control and procedures are reproducible. Now, the ISO protocols and methodology are similar to those of Standards Australia, except that ISO can give a drafting committee up to 3 years to complete a project. This said, should the ISO drafting committee run out of time to complete a project, the committee can cancel the project and raise a new work item to resume the drafting process. Resetting the ISO drafting clock is important for complex projects. For example, the revision of the current ISO 9606 to combine all 5 parts. A key point that must be mentioned is that as the Australian federal government's policy of adopting ISO standards where technically feasible, it is imperative that Australian committees review and, where appropriate, comment on the relevant ISO drafts. Our mirror committees do have access to all the relevant drafts, and I cannot underscore the importance of reviewing all draft standards, including ISO drafts. Too many countries just vote positive without reviewing the contents. If it's important to Australia, it is also imperative to physically attend ISO meetings so that Australia's views can be considered. Whilst ISO have had teleconferencing facilities available for some years, in practice until COVID hit everybody, it was often difficult to access. ISO meetings now occur regularly via Zoom, but are typically limited to 3 or 4 hours duration and start at 1 p.m. CET time in Europe. This usually corresponds with 9 p.m. Sydney time during our winter, or 11 p.m. during our daylight savings time, and 7 a.m. on the east coast of the USA. It is important to note that all ISO standards are reviewed every 5 years and are either reconfirmed, revised, or withdrawn. No exceptions. Standards Australia have also recently aligned with this 5-year cycle, down from the previous 10 years. Now, with the rapid uptake of handheld lasers, cleaners and cutting systems, it became apparent that safety awareness within the welding industry surrounding the use of these devices is somewhat lacking. And accordingly, it has now been agreed to amend AS 1674 Part 1 to include basic requirements for the use of these devices, and to point users familiar with 1674 Part 1 to the relevant Australian and ISO laser safety standards. Importantly, requirements have been drafted in consultation with the Laser Safety Committee, SF19. Now, this standard the revision hasn't kicked off yet, but it will be fairly soon. In addition, it is planned to include general requirements for fume extraction systems where the captured fume is filtered and the air recirculated into the workshop. A modified adoption of the ISO 21904 series of standards has been published as the Asnzs 21904 series and includes a minimum W3 filtration recommendation, which equates to a 99% filter efficiency. This level of filtration efficiency exceeds that for the common P2 filters used in welding and just below the P3 efficiency level. Now, equipment meeting these standards is currently readily available and has been sold to Australia for some time. Now, some of these systems also have a higher level optional HEPA filter capability. Note that it is not envisaged that existing systems be scrapped, rather existing systems should be upgraded or replaced as the need arises. Now, regarding AS 2865, which covers confined spaces, whilst the revision was planned of that document was originally intended to be managed by the committee that looks after welding safety, WD4, Standards Australia have advised that they will be reconstituting the original drafting committee, SF37, to manage this project. Now, just lastly, in the welding safety space, Part 2 of 1674 has also been revised and was published on the 30th of May last year. Main changes include clarification of the high-risk Category C environment and requiring 0 volts at the welding torch during electrode changes in Category C. This was absolutely necessary following confirmed reports of welders receiving electric shocks when damp and in Category C conditions whilst changing electrodes. For Category B welding, the use of voltage reduction devices, or VRDs, are now specifically recommended within the standard, and that came about following a recommendation by the Queensland coroner following the electrocution of a welder in 2011. Now, there's been a lot of recent activity by the various safety committees responsible for personal protective equipment, and I'll spend a little bit of time going through this. Now, Committee SF6 are currently moving to replace the AS 1338 series with modified adoptions of the ISO 16321 series. These standards cover welders' eye filters and protective visors. Note that the adoption of these ISO provisions has been long envisaged by the drafting committee, and the revised drafts have been balloted by this drafting committee and are now being prepared for publication. I don't have a date. SF53 covers personal protective equipment not covered by other committees, including welders' protective clothing. Now, ASNZS ISO 11611 was published in March last year and specifies requirements for the fire resistance and electric resistivity of the clothing. And the latest edition now includes ultraviolet protection for the wearer for both light duty and heavier duty welding and related applications. Now, the last committee I'm going to just talk about is SF10. They have adopted a range of ISO standards to replace our ASNZS 1715 and 1716 standards. The existing Australian standards will remain in use until 2030, and in the meantime, the adopted ISO standards will gradually be implemented as these standards are phased out. Now, Standards Australia ran a webinar covering this change last year on the 2nd of May 2025. Now, I'm going to deviate from this presentation slightly, and in the next 2 slides, we'll give hopefully you guys in layman's terms a quick overview of how the changes relating to weld fume protection with the impending superseding of the 1716 in particular will apply. Now, the Standards Committee advised that the age standards are being progressively superseded by a range of standards over the period 2025 to 2030. Now, these standards are all ISO based and cover the same ground that the existing current aged Australian standards covered, but they're all updated. Of importance to users, the classification of filters that are available will expand to include the 6 factors shown on this slide. Now, users should note that the standards require manufacturers to test the actual performance of each type of system they sell. This is where things have changed. Unfortunately, whilst there's only 2 testing laboratories able to conduct these tests, it will be some time before users will see product compliant with these new standards being released to market. Now, I'll give you an example of how the process works. Now, looking at the common P2 filter, which I'm sure everybody is familiar with, It's used by welders, and it's now similar to protection that's provided by what's called the F2 class. Now, for those of you who aren't familiar with this particular P2 filter, it's the same filter that was recommended during the COVID period. Now, an example designation suitable for welding would be a bit of gobbledygook for you: PC2, W1, BT, FT, WE. Now, if the filter is capable of filtering ozone, it will also include the designation OZ1, as I have shown. Now, you can see how under each of these particular items they apply. Protection class is PC2. That relates to how much potential leakage there may be in the device. There's work rates between 1 and 5. Now, a face mask will probably only be a W1, which is moderate or light work, where you're not breathing heavily. Then you've got your respiratory interface, so T for tight fitting. A is B covers your mouth and nose, and it all goes all the way up to E, which includes a full body suit. Particle filtration efficiency, F2, which is better than 95%. F3 from the P3 from memory is 99.7%, and it goes right up into the HEPA range, the F classes. And for application, specifically for welding, it's a WE, and as I mentioned, for ozone, it's OZ1, and it's relevant to the work rate in that particular situation. Now, for a PAPR, which many of you would be familiar with, by example, if one of these had fitted with a P3 or equivalent filter compliant with 1716 and loosely fitted over the face, it may likely have a designation of either PC3, W1, CL, F3 for the filtration class, WE, or PC3, W1, CL, F4, WE, or better, depending on its performance class regarding its testing results. Now, being a positive pressure device that PAPRs are, it should be noted that leakage will be minimal even if loose fitting, which is fairly normal for powered air purifying respirators. Depending on the leakage performance, PAPRs are likely to achieve a PC3 1% leakage rating, or possibly the PC4's 0.1% leakage rating. But not shown on this slide, the ISO standards have listed protection levels. However, this is an area that's currently under review. It is expected that these will be amended to better reflect real world performance in due course. Current minimum protection level offered by PAPRs is required under 1716 is 50. And that just simply means that it's the air filtered is 50 times cleaner than what it is outside the filter. Now, users should be aware that filters with higher filter ratings, which is a higher suffix numbers, generally have an increased breathing resistance at lower work rates. So just to compare the filter recommendations for fume extraction systems that I mentioned earlier, the AS21904W3 filter efficiency mentioned previously is similar to that of the F3 particle filter efficiency under the new classification system. Now, details on this and the previous slide will be included in the upcoming revision of Weld Australia's Technical Note 7 covering safety in welding. The revision of this technical note is well advanced and is currently undergoing a final peer review. Now, looking at some of the other welding standards. These are the main standards WD3 is responsible for. You will note that many of these have an ISO basis, although it is not always immediately obvious that an AS standard has its origin in an ISO document. Where relevant, affected standards will usually indicate that they have taken recognition of the relevant ISO standard or standards in the preface. Now that the definition of welding inspectors has been resolved, and that was a big hold-up for the 1554 series, the actual revision of this series is scheduled to commence once the revision of the AS 1665 gets to the public review stage. This said, I can advise that the revision process for ASNZS 1665 is well advanced and the initial drafting is scheduled for completion by the fourth quarter of this year. Under consideration is provision to address the inclusion of laser welding and additive manufacturing in 1665. Now, with AS 2214, you will note that the standard has been retitled and split into two parts at this point in time, with other parts to follow. This change provides for better integration with the ASNZS 5131 and defines recommended technical knowledge and competencies for relevant supervisors and now inspectors. Part 1 of 2214 aligns with the 1796 certificates 10 and 11, and from a structural perspective, Part 2 is specific to bolting. Both parts were published in December 2024. Whilst Weld Australia has received inquiries regarding training to Part 2, we are referring inquiries to the Australian Steel Institute, who have developed a training course. The drafting of bolting theory components of the course has been completed and a practical jig is actually being manufactured by the ASI. A number of specifiers, including Ausroads, are moving to mandate qualifications to Part 2 for bolting applications as soon as people do become qualified. Now, WD3 has taken responsibility for the age standards produced by a couple of inactive committees, these being WD1 and WD6. Whilst their standards do not need active revision on a regular basis, their standards are critical to industry. The WD1 standards cover terms and definitions, including welding positions, and WD6 standards cover the AS2205 destructive testing series. These types of standards rarely change or need to change, so generally can be reconfirmed. There are, however, exceptions from time to time. Now, do we have any questions at this point in time?
Yes, we do, Bruce. There's one here.
Yes, please.
What are the major changes observed in Australia, New Zealand 1554, and any changes in essential variables?
I can't answer that question. It's a bit premature because the committee hasn't looked at it yet. So once the committee looks at it, we can advise on that. So hopefully we're going to clarify and simplify some of those essential variables. We generally try not to mess around with them too much.
Okay, one more. If ISO 9606 is being adopted, sorry, this is more a comment.
Oh, okay.
If
Yeah.
ISO 9606 is being adopted, then the essential variables are reduced.
I will comment on this perhaps a little bit later, but with 9606, the essential variables of 9606 itself will apply over those of the 1554 series. Now, the 1554 series, you can allows a welder to qualify to 9606 specifically, or at the fabricator's discretion, usually it allows the welder to qualify to specific weld procedures. So, and the essential variables are somewhat different, but 9606 is usually a welder who has got higher capability, and therefore they allows a broader range of options. So that's a fundamental there.
All right, I've got two more.
Oh, okay, righto.
Is Australia, New Zealand 5131 being replaced by ISO standard?
No, not at this stage. There is an ISO standard that has been written, but as far as I'm aware, 5131, it's not currently intended to replace it with the ISO standard. That said, however, AS 4100 is undergoing revision, and as a consequence, 5131 will need to be revised in the near future.
Okay, another one.
Coming thick and fast here.
Yeah, they are. Is ISO and AS standards equivalent for welding? And then they've got AS3992 to EN ISO 15614-1, EN ISO 9606-1.
Okay, 9606-1 is specifically welder qualification. The European standards call up 9606 specifically, no exceptions for welder qualification. 3992, which is our Australian pressure code. I haven't done a comparison of acceptance criteria on it, so I can't comment on it. The 3992 does tend to follow a lot of the principles of ASME, which is different to some of the stuff that's in 15614. If your specification calls up a specific standard, you have to follow that standard. You just can't chop and change. That's risky.
Okay, next one. Changes in Australia New Zealand 1665 to include PQR qualification pipe to pipe and pipe to plate connection, and include what relevant testing is required.
We are including that in the drafting process, so yes.
All right, and one more. What is happening to the Australia New Zealand 2980 dairy tube qualification under New Zealand conditions?
Yet to be resolved by HERA. So that will be under discussion, but that will have to be considered once 9606 is revised and republished in Australia, which will be a little while off yet. So no decision has been made at this stage as far as the New Zealanders are concerned, but the decision will be made in consultation with New Zealand on that point. We may in fact have to. An option may be to run 9606 as a modified adoption to include that in, but I don't know.
Okay, thanks, Bruce.
All right, moving forward. Now, back in 2022, Weld Australia identified some issues relating to 1674 Part 1 on fire precautions and linked to this AS 2812, particularly around the definition of hot work and flame brazing. So 2812 was duly revised and republished in June 2024. But just recently, though, Standards Australia advised that due to a publication error, a number of diagrams in that standard were missing, and this has now been fixed. Now, regarding AS 1101 Part 3, which is the drawing standard, Standards Australia have been aware for quite a while of some minor errors within that standard. Now that covers general symbols for general engineering, Part 3, welding and non-destructive examination. Unfortunately, due to resource limitations, these errors were unable to be immediately addressed. However, I can report that a project kicked off in 2025 to correct these reported errors and at the same time update non-destructive testing terminology from NDE to ND2 in consistent with common usage and also ISO usage. Now, the public comment process has now been completed and comments received are being resolved, and a committee ballot draft is actually now being prepared for which is the next step in the publication process. So in coming months, I would expect a new edition of that standard to come out. Now, the last standard I just want to comment on briefly here is the revision of the fillet shear testing standard, which is AS 2205 Part 8 Part 2. It's probably not relevant to most people here, but it was requested by manufacturers security fencing, and it now caters for an expanded range of welded joints, so round bar to round bar compared to just plate to plate as in the old system. Now, just covering AS or the ME1 standards at the moment, which is your pressure equipment. There's currently 25 standards that are active. Now, the standard 3788 covers in-service inspection of pressure equipment. It was revised and published in June 2024, but it has been noted that it does contain some minor errors in the standard, particularly in Table 4.1 and Section 9, requiring an amendment to correct it. I am also aware that a number of users are asking some very specific questions as to changes in the content of this standard. However, these need to be directed to Standards Australia to ascertain that an error has not been made during the revision process. ME1 are currently revising another standard, AS 4343, which is hazard levels, and AS 3992. Now, public review of both of these standards has been completed and comments received have been resolved, and the drafts are now being prepared for committee ballot. Now, Weld Australia has also been asked to lead a revision of AS 4458 on manufacturing of pressure equipment, and I can confirm that a working group has held quite a number of meetings over the last 2 years, with the initial drafting process being well advanced. Some issues with material groups has been encountered and identified, and these have been being addressed in the revision of AS 3992. Once completed, the draft will be submitted to Standards Australia to be utilised as the basis for a formal revision process, as I've mentioned, process. So this has actually proved to be a very, very big revision process on this standard. Lastly, at long last, the revision of 4041 on pressure equipment or pressure piping has commenced, with a drafting committee formed and a team leader and drafting leaders appointed. Being a very large document, this will be a major revision.
Hi, Bruce. We have another question.
Certainly.
All right. Can you expand on the update on NDT terminology? NDE should be in an examination where no applied power source is done, and NDT should be those tests that require an application of a power source.
Okay, I'm not going to get into the wording semantics, but the Americans and the purists all talk about non-destructive examinations, as a lot of our standards have. However, the committee MT007 has decided to just to drop the MDE term and just run with NDT for non-destructive testing. That is the general way that people talk about the process. They generally don't talk about NDE other than in standards and in writing. So it's not in common usage. So standards have decided, or Standards Australia through MT007, which is the committee that looks after all of these NDT processes, has recommended we adopt the ISO terminology, and that's the way we're going.
Thank you. We have one more question. Are there any plans to update AS 4037?
That I think covers NDT of pressure equipment. The answer to that is yes. A new chair has been appointed, but we work on that is yet to commence. We're just holding off on some of the other pressure equipment standards first to get them well underway and past the public review stage, and then whatever comes as the drafts are prepared will then come forward. So 4037 is definitely on the hit list.
Thank you. And another one's come through. Are the errors in Appendix G of AS 3992/2020 corrected in this revision? PH/PJ weld positions 5G up and down are currently listed as 3G up down.
Yes, they are being corrected, but I will double check.
Thanks, Bruce.
Righto. Now, whilst the design standard 4100 underwent a revision in 2020 to remove the fabrication components from the standard and refer to 5131 for all fabrication requirements, it now requires a long awaited major revision. Now, I know that ME1 or BD1, sorry, have been talking about wanting to do this for many, many years. And I've been to many a presentation given by the chair of that committee on this. Now, the major revision of 4100 is now well underway. And as I'm speaking, the draft is currently open for public comment. So if you go onto the Standards Australia website and to go to the public comment portal, you will be able to access it and review the changes. This has actually been a major revision over about nearly 2 years, led by 5 expert teams, with the standard being updated to align with current best practice. Of note to fabricators and design engineers, the lamellar tearing provisions within have been revised to clarify some requirements that were seen as too conservative and overly restrictive. While similar to those now published within ASNZS 5100 Part 6, they have intentionally taken a more informative approach within 4100. Now, associated with the revision of 4100, as I've indicated before, the need to revise 5131 has been flagged, and preparation of a revision project submission is currently underway. That revision will probably be led by Dr. Peter Key from ASI.
Hi, Bruce. So we have another question.
Yeah.
Can Ian ISO 9712 Level 2 person certify the ASNDT standard examination?
You probably got me on that point. I really don't know. I take level 2s I think can sign off reports, as can level 3s, and level 2s and level 3s can supervise a level 1. We are including some clarification on some of these points within 1665 based on wording that came from MT007 and agreed with the Standards Australia editors. We had to be very careful how we worded that. I hope that it's probably not the answer you're seeking, but it's as best I can answer on that point.
Thank you. And one more. Is it intended that the traceability requirements of Australia New Zealand 5131 be better explained in the next revision?
You betcha. There are dogs breakfast at the moment, not intentionally, but yes, that is definitely on the hit list.
Thank you.
Now, these are the standards on the current screen that MT07, which looks after non-destructive testing, is responsible for or has an interest in. Now in quite a few of these cases, the adoption of ISO standards to replace some of the aged NDT standards has occurred. There are some ISO standards listed that have not been adopted, and they may be considered in the near future. Standards Australia withdrew the old AS 3978 in 2019, but it has been restored as an active standard despite its age. Now, a project to revise 3978 is well advanced, and the committee ballot has been completed now, and it will be published, I hope, sometimes during the second quarter of this year. Now, one of the key things that's happening in that particular revision is all reference to welding will be removed, and I think it'll refer to ASNZS ISO 17. I think it's 637 off the top of my head that looks after visual examination. Now, MT007 is actually working very closely with WD3 on the revision of 1665, and it will liaise with the revision of the 1554 series in due course. Now, the ASNZS test series, which are covered by WD6, that no longer exists. Some of them are direct text adoptions or clones of relevant ISO standards. So those marked ASNZS are actual clones, whereas the straight AS ones are Australian standards. Other standards shown in italics are aged and are over 20 years old. This does not invalidate them, as it is rarely necessary to revise mechanical testing standards. The World Tensile Testing Standard and Sharpie Testing Standards have both been revised by ISO, but there are currently no short-term plans to adopt either of these ISO standards, even though AS 1391, for example, is a clone of the ISO Tensile Testing Standard. To adopt the ISO weld testing standard, which is ISO 4136, a modified of the adoption of the ISO standard is likely to be required. And as mentioned previously, the shear testing standard was revised to cater for shear testing of bars and welded fabric, and it was published on the 3rd of July last year. Now, that particular standard 2205 Part 8, Part 2, does include some components from a relevant ISO standard for testing of reinforcing, but we've actually made it broader than just reinforcing. Now, on the welding consumable side, most of the consumable standards now used in Australia are direct text adoptions of ISO standards or modified adoptions. Some of these standards are being revised by ISO, and updating these to the latest ISO editions will be considered once ISO have completed their revision process. Now, regarding the manual metal arc standards, should fabricators need to import the ISO equivalents from Europe or ISO or elsewhere, this is permissible and it does not affect any pre-qualification status. It should be remembered that the Australian standard numbers have been used to identify the Asnzs version of the direct text adoption of these ISO standards, primarily due to the fact that the attended Asnzs ISO numbers that would have been used were already in use by other standards in Australia and would be thoroughly confusing to users. The last point I want to make from this key point I want to make on this slide is AS/NZS 2576, which covers hard facing, is being revised and public comment has been resolved. The committee is currently sourcing updated photo micrographs of various microstructures of the standard, and the standard will be published once this process is completed. The focus on the AS/NZS 2576 has been to align with some ISO provisions where appropriate, and when published, ISO TC44SC3 has actually expressed an interest in using this Australian standard as the basis for an ISO standard on the welding of hard facing. Now, regarding the bridge standards, 5100 Part 6 from the Bridge Code has been amended, and I'll say a little bit more on this in a moment. Now, 1554 Part 2 was revised some time ago, but since publication, an error has been found in the threaded stud loading tables. The table is fundamentally correct for the stud types listed. However, it was only reported after publication that these stud grades are not those typically used for threaded studs. A minor amendment will be required to fix this in due course, but this process has been delayed due to a need to improve the method to validate the performance of these threaded studs. Now, ISO 13918 on steel studs was adopted as AS/NZS ISO 13918 in 2020, and importantly, provides access to a variety of stainless steel studs. Revision of ISO 13918 recently commenced and is currently at the committee draft stage. Now, AS4671 now includes reference to two new high-strength reinforcing steel grades, these being 600N and 750N, and at this stage the reinforcing industry has not progressed the need to revise Part 3 of 1554 to consider the welding of these new materials. Now, the Bridge Design Standard 5100 Part 6 has been amended to remove some anomalies between it and AS 4100. AS 5131 and the New Zealand Standard NZS 3404 Part 1. Of particular note, the provisions for the management of lamellar tearing were seen as too conservative, as I previously mentioned, in some circumstances, and the provisions were modified to address these. The modified provisions are finding their way into other standards, including the current revision of AS 4100, and work to revise and produce a commentary on this standard is now well underway. Now, until recently, age standards were defined by Standards Australia as standards published 10 years ago or more. Age standards can be problematic, particularly if the original drafting committee is inactive. And in some cases where the work is transferred to another committee, the standard can be reconfirmed or revised. But if it is missed, it can be withdrawn, and that creates problems. For example, hoses for welding gases, which was AS 1335, was withdrawn as the drafting committee no longer existed. However, it was still required, and with the assistance of Standards Australia, ISO 3821 was actually adopted as Asnzs 1335 via Committee ME2. Now, regarding AS 1988 Part 1, which is the welding of ferrous castings, particularly Part 1 steel castings, it has also been withdrawn, as has AS 2074 cast steels. Now, that is proving problematic for the foundry industry. Now, Standards Australia are now following a similar process to ISO, where its published standards undergo a systematic review every 5 years to maintain currency. And in the case of ISO, the standards will be reconfirmed, recommended for revision, or withdrawn. In the Australian situation, unless resources improve to enable revision, it is likely we will see recommendations for a lot more ISO adoptions or modified adoptions on a more frequent basis. It is therefore imperative that Australia is represented, as I've indicated, and active on the relevant ISO committees. Travel subsidies are available in many cases for delegates to access, and increasingly, many ISO committees are meeting electronically or hold hybrid meetings, albeit at awkward times for Australians. Now, looking at the ISO updates. Now, ISO TC 44, Subcommittee 10 and Subcommittee 11 are active subcommittees, and Australia is representative on both of these committees. Numerous comments have been presented by Australia's representatives based on our local experiences with these standards, and our views have been well received and considered. As I've previously noted, ISO 17607 has been published in 6 parts, and Australia was active on this particular committee, TC 167. Importantly, ISO took cognizance of the contents of 5131 during the development of the early drafts of that particular ISO standard. So that is the potential replacement for 5131, but it's not intended that that will occur at this point in time. Now, TC 167 have also instigated a new project for structural bolting coordinator based on the principles of ISO 3834. Now, the proponents for this bolting supervisor Part 2 of 2214 were aware of this proposal and have taken cognizance of these early drafts to ensure alignment with the Australian Part 2 of 2214. It is important to note that not only are our trading partners active on these ISO committees, so are our competitors. So Australian participation is imperative, or we could find ourselves standardised out of our own market. Of interest to our New Zealand cousins is the project on welded joint performance for seismic steel structures. Now, in 2021, Weld Australia published Australia's first standards map, which you can see an example on the screen. And it is available for free download from the Weld Australia website as Technical Guidance Note TGN SG07. By referencing this map, users will be able to locate the subject area and then identify key standards used in this application at a glance. Version 2 of this guidance note was published in 2024. Now, for users of ISO standards, in particular the EN version of ISO standards, The Swedish Welding Commission has mapped the ISO standards used throughout the European community. It was drafted by Matthias London and is periodically updated. It can be downloaded via the Swedish Welding Commission's website, which you can see on the screen there, and it was last revised in March of this year. And I can say unashamedly that excuse me, when we drafted the Australian version of this document, we did copy the format, although the content is different. Now, just before I finish, I would like to give an overview of standards interpretation requests, because these do come in from time to time and they do cause grief. Before you submit any interpretation request, please read the standard in full. Do not read the clause by clause or paragraphs in isolation. You will simply waste everybody's time, including your own. Now, you need to submit your question in writing, but there are 3 very specific requirements to adhere to. Firstly, clearly state the identity of the standard, the addition, and if any amendments are applicable to the question. Secondly, state your question very clearly and concisely, giving a very brief description of the scenario and identify the specific clauses, tables, and requirements. Thirdly, prepare your proposed response in a way that the committee can give either a yes or no answer. If the standard is silent, the committee will respond accordingly. An interpretation can only clarify the intent of the standard. It cannot change what is written. Now, requests for ISO interpretations are managed by the relevant Australian National Mirror Committee. If the local committee cannot resolve the question, then they in turn will submit the question to ISO for a formal response. Users who send their interpretation request directly to ISO will either be ignored, or in some cases they will very kindly refer the inquirer back to their National Mirror Committee. Importantly, I would beg you, please do not flood the committee with requests or ask it to resolve commercial disputes, because that will not happen. Most issues can be resolved if people read the standard in full. Be aware that for matters that relate to clarification or application, drafting committees are under no obligation to reply to the inquirer. Now, if on the other hand, a potential error, anomaly, or safety issue in a published standard is confirmed, the committee is highly likely to respond accordingly and act appropriately to deal with the relevant issue as resources permit, time permits. Now, this will be the second deviation from today's proceedings. Now, before I summarise the outcomes from today's proceedings, by popular request in the next 3 slides, I would like to give you all a very brief overview of the situation regarding requirements for the control of weld fume coming up as of the 1st of December this year as it approaches. As many of you would realise, the situation continues to be somewhat fluid, although the fog is now starting to clear, so to speak. Whilst there is currently no Australian standard that specifies requirements for weld fume, Weld Australia continues to revise and publish their technical guidance note, Fume Minimisation Guidelines, which is actually based on research by the then WTIA and CRC for Welding and Joining in 1997. This document continues to provide guidance to users on fume control requirements based on worst case welding conditions, in other words, still air. Now, the current editions of these guidelines do take recognition of both IARC's ruling on weld fume and cancer, and Safe Work Australia's revision of their workplace exposure standard for airborne contaminants, published on the 18th of January 2024, which reduced the exposure standard for total weld fume from 5 milligrams per cubic metre to 1 milligram per cubic metre on a time-weighted average of exposure over an 8-hour working day. Now, come the 1st of December 2026, which is in a few months' time, these exposure standards, or WESs as they are referring to, will be replaced by what's called exposure limits, or WELs. These will include some additional changes, which include a reduction in manganese exposure and limits on both what's called the inhalable fraction and the respirable fractions. Inhalable fractions, for those of you who are not aware, are the fractions of the fume that the nose and body mucous membranes and the like can trap and then expel. Whereas the respirable fractions, which are the really fine particulates, are those that can go straight through into the lungs and into the bloodstream. Now, a requirement that has been included, that exposure to chromium-6, which is generated during the welding of stainless steels and high chromium steels. It is what's called a non-mutagenic carcinogen. And exposure to this material must be minimised as far as reasonably practicable. There's no specific minimum limit on it. It just has to be minimised.
Sorry, Bruce.
Now, just hang on. I'll just finish the slide and I'll be with you. Now, cobalt exposure will reduce from 0.05, a time-weighted average, to 0.02. That will potentially affect hard facing. Please note that in late 2025, the standards, the exposure to aluminium weld fume was reduced to 1 milligram per cubic metre. However, the exposure standard for copper weld fume remains currently under review. Now, lastly, to assist the industry, the ISO 21904 standard series on fume capture was adopted as modified adoptions to provide guidance on the filtration requirements where captured fume is specifically filtered and filtered air is recycled into the workshop. Now, fire away.
Okay, we have a question here. If fume is captured and removed from the workshop, for example, then there is no requirement to filter the weld fume?
There's no requirement to filter it prior to discharging external to atmosphere. If you capture it and recirculate it into the workshop, all you're going to do is build up a big blue haze inside the workshop and make your workforce very sick in very short space of time.
Okay, we have another question. Will Standards Australia have a portal to publish interpretations to prevent multiple people asking the same question, similar to ASME and ISO do?
That would be a very good idea. I haven't heard of any such a system in place, but it's certainly something that it's an improvement request that Standards Australia could be asked. Just bear with me. I will make a note of that request in my notes, and I'll ask the question. Excellent feedback. Thank you very much, Lee. I will definitely pass that comment back on to Standards Australia.
Thank you.
Now, and just another slide on this. Now, despite all the doom and gloom relating to weld fume, there are options available for users of welding process to help themselves. In some European countries, there's a requirement for consumable manufacturers to produce what's called fume data sheets based on 90% of the maximum recommended welding current. They are not universally required as far as we are aware, but definitely are required in Germany and some other countries where the fume limits are similar to Australia. The driver for these documents appears to be an EU roadmap to carcinogens. These data sheets are particularly helpful when conducting a risk assessment. Now, it is recommended that Australian users ask their suppliers for copies of these data sheets. Now, if the consumable is sourced from Europe, the sheets will most likely be available. If they're sourced from elsewhere, they may not be. But if you don't ask, you won't get. Now, real-time fume monitors, which I have spoken about in the past, are readily available, and they are particularly useful for estimating the fume exposure for people working near welding operations, but they are not a substitute for formal air monitoring assessment by an occupational hygienist. In all cases, start by conducting a risk assessment, and the hazards to health and safety must be identified and controlled. The regulations, though, do not tell you how this must be done. As you can expect, there is no one-size-fits-all approach to weld fume control, and each work site and relevant control options should be individually assessed. Now, Weld Australia's engineers can help with this process. Now, just briefly, Weld Australia does offer fabricators a number of options to help them identify appropriate controls to minimise their emissions on weld fume. Now, our fume guidelines are an excellent place to start, and the QR code that I've got on the screen will take you to the Weld Australia website. Click on the resources tab once you get to the website and apply the technical guidance note filter on the left of the page. The document is free to download and contains a lot of useful material and advice, which is briefly summarised on this slide. Some key points to remember are that there is no one size fits all in regarding to fume control. Every fabrication shop is unique to the type of work and layout, and regulators promote fume capture by a variety of methods, but not all methods are equal. On-gun extraction should be considered given the improved technologies currently available, but not be suitable or effective when welding out of position or where access is somewhat limited. Alternative controls need to be considered where the risk assessment is really important. Secondly, where there is little evidence of serious consideration being given to the use of fume capture, it will raise doubt in the mind of the regulator's inspector should you get a visit, and they will ask for a formal air monitoring assessment by a hygienist to demonstrate that the controls in place protect both the welder and people from nearby excess fume exposure. Powered air purifying respirators are highly effective at protecting the welder, which is usually the wearer, including from ozone exposure. Fume capture devices, though, are ineffective against ozone because ozone forms remote from the arc wherever there's UV. Now, Weld Australia also operates a free fume hotline to assist fabricators in assessing their control requirements. The number is 1-800-212-988, which is shown on the screen. And most importantly, Weld Australia's engineers are offering a new service to members and are now able to perform a safety audit for fabricators for a small fee, including a written report on recommended controls. Call our general number, which is 1-800-189-900. Now, finally, Weld Australia and Safe Work New South Wales are conducting a free online webinar to assist industry on the coming welds on the 29th of April. Register via Safe Work New South Wales or Weld Australia's events page. The New South Wales Weld Australia Committee is also organising a weld fume mitigation events Now, one of these will be at Wagga on the 23rd of April, and there will be a second one of these at Orange on the 25th of June.
All right, Bruce, sorry, we have a question.
Certainly.
We've got two now.
Okay.
With the recent update of AS 1796, Cert 10 and Cert 11 perfectly catered to supervisors and inspectors certification for Australia. Could Weld Australia consider reintroducing the excellent course for CQCWC and introduce a Cert 12 for welding coordinator?
Excellent question. It's certainly there are Weld Australia people online, and it's a question that can be taken on notice. I know that there is a Cert 12 under consideration, but not for, and it could be used as the basis for welding coordinator, but that's under consideration at the moment, but there's nothing concrete in progress yet.
Okay, thank you. Next question. We have EN, ISO, IS, and ASME standards for welding qualification if we have to qualify WPS, PQR, WPQ as per Australia New Zealand standards. So can we harmonise AS standard to EN, ISO? Please guide us.
Okay, if you have to comply with the EN ISO standards, you have to do everything that they require. That said, now 1554 and I think 1665 in due course will be very similar, in that once you have qualified a weld procedure to another standard, the Australian standards generally do not require you to then go ahead and re-qualify that same weld procedure, because once the procedure is qualified with the series of tests that need to be done, we know that the procedure is going to work. The key thing is, are the weld metal properties are appropriate? Now, with the ISO standards, the testing required is generally a lot more extensive, similarly with 3992. So we're not going to ask you, if you've got to do full qualification process, to repeat that process. The worst case scenario is if you've got it qualified, you may be asked, particularly if someone has given you a copy of the procedure and you are approved to use that procedure, you will be asked to run a macro. And the reason for running the macro is specifically to demonstrate that, yes, you can follow that weld procedure. It's not to reproduce it in any way, shape or form, but demonstrate, yes, you can follow the procedure. So that's what the idea of the macro is in general, is to demonstrate that you can get the appropriate weld penetration. As we know, if everything is kept under appropriate control, your weld metal properties will be more than adequate.
Thanks, Bruce.
Okay, the last slide coming up. As standards are evolving, it is important that users stay abreast of the changes. There are 3 ways of doing this, at least that I'm aware of. Now, Intertech, which was formerly SAI Global, has a standard watch program that users can sign up to and get notification when changes occur, including release of revisions for comment. Now, Standards Australia also publish a review list of standards for public comment, and you can subscribe to standards news updates. Lastly, Weld Australia publishes, it's now going to be a 6-monthly update in the journal. It used to be quarterly. Now, and we do produce a quarterly, the 6-monthly report of what's happening in the standards and what's coming up. With the longer delay, it just, unfortunately, we won't be able to tell you when standards are coming up for public review. Now, everyone can be involved in the standards drafting process by commenting on the free publicly available drafts during the 2-month public comment period. These can be accessed via the Standards Australia website at www.standards.org.au, but be aware that you will need to create an account and log in to access the draft for comment. That's the reason for that is it takes the comment is linked to yourself, and then when the committee then reviews your comment, you then get an email back on the committee's response. This said, when a standard is being revised, download and comment on its draft, please. If you don't comment, it will be assumed that the proposed changes are perfectly acceptable, warts and all. If you do comment, clearly state what should be changed and why, and provide draft text for consideration. Members of the primary standards committees are appointed by various nominating organisations, which Weld Australia is one, and are usually experts who typically set strategy and manage the revision process. It is these committees that have input to ISO drafts. Drafting, though, is often done by industry experts, not the main committees, and representatives on designated subcommittees or working groups are often engaged in this process. So if you're wanting to be involved in some of these working groups, that can usually be considered, provided that the working group has got balanced reputation or representation across the industry. Lastly, if you hear people denigrate the move to ISO standards, just remind them that with over 250 welding-related standards to maintain, the resources to manage these standards no longer exist, as companies who formerly sponsored their technical experts involved in standards writing no longer do so. So given that manufacturings have largely been sent offshore, which we are all suffering for as a result. So on that note, I now invite any questions.
We have one here. AWS/CSWIP welding inspector, can it transit to AS2214 inspector?
The American welding inspector can translate across in part. The only unknown is does that inspector have knowledge on the relevant Australian standards? So there's certainly the inspection side of the expertise can usually come across, but it's a matter of the certification body as to whether they accept that.
Thank you. And one more. IWE, can it be the equivalent to the welding inspector certificate?
No, totally different.
An IWE degree can get the Cert 10.
The IWE can sit for a Cert 10 if they've got the prerequisites. The IWE people are not trained to the degree necessary in the application of standards. They've certainly got a lot of the technical knowledge side of the standards requirements, but they are not necessarily trained in the detail, and they're certainly not examined as far as the application of the application standards are concerned. The same applies to 2214 as well.
Okay, any other questions? Oh, just examination or should attend the courses?
That's up to the certifying body or the examining body. If the standard doesn't require you to attend courses, but keep in mind that the failure rate of people who don't attend the courses and just sit the exams is usually fairly high.
Okay, another question. Who can certify as 3992 procedure?
That is usually a matter for the fabricator to work out, and it's usually written into or should be written into their quality management system as to who authorises the weld procedures. Now, if there's nothing written there, or sometimes you get clients will have certain requirements for who authorises weld procedures. Inevitably, certain clients will usually request that their their welding inspector or their representative witnesses certain weld tests, in which case, if they are required to witness weld tests, then they will then countersign the weld procedure to go with it. But certainly a welding supervisor should be able to draft and authorise weld procedures, but it comes down to who's authorised to do so in the fabricator's quality system.
Okay, and just another comment, fabricator, welding engineer, or other competent authority?
I'm not sure what the question is getting at there.
Okay. Any other questions from anyone? No? Well, thank you very much. Oh, sorry. No, we do have another question. In Canada, the CWB certifies WPSs for structural and similar regulatory bodies for pressure equipment. Has Weld Australia considered offering a WPS approval system to improve the quality of WSs overall in the industry?
Probably not. From time to time, there has been thoughts. People have asked about, can we come up with some standardized weld procedures that we can then sell to people? But I don't think anything concrete has come from that particular process. But if people are certainly interested in Weld Australia uh, doing some type of weld procedure certification process for companies and the like, I think it would be a case of raising it with our engineers, and it potentially may be a service that could be offered down the track.
Thank you. Are there any other final questions today? If not, thank you, Bruce, for a very informative presentation. This session has been recorded and it will be emailed to everyone that registered today. Thank you very much for attending for this critical topic, and we hope to see you at future events. I'm going to end the session now. Thank you.
Thanks, Charlotte.